Now, dear students, now I'm going to start lecture number 16. Now, explanation of the electrochemical cells. So, first electrochemical cell is a electrolytic cell. So, this electrolyte cell is a non-spontaneous. Redox reactions are non-spontaneous, and we have to pass continuously electricity. Then the chemical chain takes place. So, many examples are given here. So if you open the next page, 168, the diagram is given. Now I am going to explain this one. First this general one, then I will give example the common one, how to pass electric current through the sodium chloride, potassium chloride like this one. So if you see, this is the container. Electrolytic container. This electrolytic container contains electrodes. These are the electrodes devices. I told you you can use platinum as electrode, very good electrode, and also carbon graphite electrode can be used also. There are many other examples. So these are the electrodes. There are two types of electrodes, anode and cathode. Two kinds of electrodes, anode and cathode. So suppose this electrode is called anode. Anode positive, and this is called cathode. Negative. Anode has a positive charge and cathode has a negative charge. So, dear students, first I am going to explain a simple electrolytic cell. I am not going to use an aqueous. Just I put the molten any salt, molten sodium chloride, molten potassium chloride. So in your book, the general example is given. So I have to write general, then I will give original one. So just I put the molten sodium chloride. So in general, how I write this sodium chloride? M stands for metal. M stands for metal. Sodium. X stands for halogen, chlorine. Suppose this is a potassium chloride, suppose this is a sodium chloride, suppose this is a potassium iodide, solid, and I am going to heat. I am going to heat, so it melts. So I put here molten salt, molten sodium chloride, molten potassium chloride. So when I want to heat, it is split into positive ions liquid and negative ions liquid. This is a molten form. Molten. This is a molten salt. So dear students, when I am going to pass electricity, here is a battery. Here I use a battery source. This is a battery. सर मैंने सेकंड शुरू किया हुआ सेकंड है अच्छा चल रहा ठीक चल रहा है ठीक So this is the battery I use for conduction of electricity. So this is the anode positive. So positive terminal is connected with the positive anode, and negative terminal of battery is connected with the negative of the cathode. Like this. Positive terminal of battery is connected with the positive electrode, anode, and negative terminal of battery is connected with the cathode, negative. And I told you there is a molten salt. molten. So now, dear students, what happens? The negative ions, halide ions and negative ions, chloride ions, bromide ions, halide ions, they are negative ions. They must move towards the anode. They must move towards anode, negative to positive. And dear students, the positive ions, the metal positive ions, they must move towards the cathode because metal has a positive charge and cathode has a negative. So when you are going to pass electricity through the molten salt, X stands for the halide ions and M stands for any metal. This is a general reaction I am telling you. So there will be a oxidation reduction. We done this. This whole chapter is based of oxidation reduction. And I am talking about the electrolytic cell, which is non-spontaneous. Non-spontaneous means we have to use a source, battery. Then the chemical change takes place. Electrical energy used to derive the chemical change. So that's why I use battery. Now students, oxidation reduction takes place. And there is a one very important thing. At cathode, always reduction reaction or reduction process. Always at cathode reduction. Reduction is a gain of electron. Reduction is a gain of electron. So at cathode, always reduction and negative and positive ions move towards the cathode to make a reduction. So gain of electron taking place. Dear students, at anode, always oxidation. Oxidation process takes place at anode, and we done in detail in the previous lectures. Oxidation is a loss of electron. Loss of electron is called oxidation, and gain of electron is called reduction. And gain of electron, how I know? By decreasing the oxidation number. And how I know the loss of electron? Increasing in the oxidation number. So again I am telling you that this is the cell, electrolytic cell. We have a container. It contains molten salt. There is a molten salt inside it, and these electrodes are dipped in the molten salt. They dissociate into positive ions and negative ions, and you see this chemical equation, general. Then you have to dip these two electrodes. One is called anode and other is called cathode. At anode they are positive means electrode, and it always oxidation takes place at anode, and there will be a loss of electron. On this side, you are seeing this is a cathode. This is a cathode, and cathode there is a reduction, and negative charge is present and cathode, and there will be a gain of electrons. So negative terminal of battery is connected with the cathode, and positive terminal of battery is connected with the anode, and then there will be a now chemical change. Chemical change takes place. And the condition is that you must put electrolyte. It should split into ions. If I put glucose, no change. If I am going to melt the glucose, no change takes place. Nothing will be happening because no ionization, no ions taking place. I told you earlier electrolyte, non-electrolyte and conductors. Now, after explaining this by using diagram, then you have to write the chemical equations of cell. We done. Oxidation half cell reaction and reduction half cell reaction. And I mentioned here, oxidation always at anode. And arrow, this arrow indicates that negative ion must move towards the anode. And these positive ions must move towards the cathode. and there will be a reduction and there will be oxidation. Now, dear students, I am going to write here oxidation half cell reaction. Oxidation half cell reaction. Here, this one, this side, at anode, this side anode oxidation, and these negative ions are going to be collected here. So these are the negative ions. These are negative ions in the liquid form while passing electricity. So they are going to be changing neutral, zero, by the loss of electron. I will write the number of electron later. Loss of electron. Now, dear students, these gases, chlorine gas especially, will prepare in the down cell. There is a special example is given for down cell where I prepare chlorine gas. So chlorine gas must be in the molecular form. It does not exist in atomic form, molecular form. So when chlorine gas is formed here, this X2 chlorine gas is going to be formed here. So it must, I will write in this form. So these we must multiply here too. Then there will be oxidation of 2 electrons. Yes, like this. There is also a process. There is also another process. Or after writing this, you should see very well. After writing this, if you write like this one. If you write like this one, then this atom does not exist. Then what you have to write after this? Then 2x means 2 atoms of chlorine to form a chlorine gas like this one. Because does not exist. This X chlorine atom does not exist. So that's why these atoms combine to form X2 in next step. Or write directly, no need for writing this step, 2 halide ions by the losing 2 electrons, by losing 2 electrons to give a halogen molecule, chlorine molecule. So this is, it's your choice to write both are correct. Because this halogen atom does not exist. So dear students, at anode you will get the gas. So I can collect chlorine gas here. Chemical change. Electrical energy derived to chemical change. Sodium chloride, potassium chloride completely now this was changed into chlorine gas. This is a chemical change. On the other hand, on here you can see this is the cathode. So cathode, this is a reduction half cell reaction. In the reduction half cell reaction, you are seeing the metal ion in liquid. Metal ion. So by the gaining electrons, because at reduction gain of electrons, it should be plus electron. I will write electron on later, and you will get the metal solid. First it formed in liquid, then you can solidify it. First sodium is going to be formed, or potassium is going to be formed because temperature is high. So it is in the liquid form, then you can solidify it. So in the last end you will get solid by this metal zero charge. Dear students, in the previous oxidation reduction reactions I told you these redox reactions, these electrons should be equal. The loss of electron or gain of electron, they should be equal number. If there are loss of 2 electrons, it should be gain of 2 electrons. If I write 2 electrons here, it must be 2. That's why you have to balance. Yes, this is for balancing. This metal can exist in atomic form, but because of I have written 2 electrons here in this half-cell reaction, which is oxidation half-cell reaction, so I must, in the reduction half-cell reaction, must write the 2 electrons. Now there is a balancing here. So these are 2 half-cell oxidation and half-cell reduction. So when you add, this is the complete or overall reaction. It's a complete reaction, or we call it overall reaction, we call this one. So this, if you understand this process, all the electrolytic process you can understand well. So that's why you have to understand what's anode, where the oxidation takes place, and what is oxidation, and what's the cathode, electrode, and what happens at cathode, and what's the reduction, and how I write the half-cell oxidation reaction and half-cell reduction reaction, and how I mention the number of electrons, and what's the way of writing the chemical equation here, either in this form or in this form. It's your choice to write, but the number of electrons should be similar in both cases, because oxidation electrons and reduction electrons must be same, equal. After adding these two, sum of the 2 cells, half cells, so electrons should be cancelled. No electrons are mentioned here. So this is the general example for the electrolytic cell. Again, I am telling you, in the electrolytic cell, electrical energy derived to chemical change. So this is the industrial application for the preparation of different metals and also gases. Chlorine gas is a very important gas we use as a disinfectant. We put in the water, disinfectant. Sodium is a very important metal we use in the sodium vapor lamps, and there are many other uses. So we prepare here. Another thing also we will do in the next chapter, maybe sodium is a very reactive. Dear students, sodium is a very reactive. Chlorine is also. So I don't put sodium metal in normal container, normal jar, normal bottle. No. It's a highly reactive. It reacts with the atmosphere, oxygen as well as moisture. Don't pick sodium metal by your hands, by your fingers, because the moisture is there. Maybe reaction taking place. So that's why always I put sodium metal when I prepare in an inert solvent. Inert does not react. No reaction with the metal. So kerosene oil. Kerosene oil, full bottle, not half. If there is a half, there is also air, it contact with the sodium metal. So kerosene oil must be full with the kerosene oil, and then you have to put the sodium metal and tight, because there is no contact from the air outside, so this does not react. So be careful, don't put in water, high explosion. So that's why this is preparation. Now if you see, now I'm going to change this. Actually, there is a self-assessment exercise. In the self-assessment exercise, 7.5, escape in electrolyte cell for the electrolysis of fused potassium chloride. When I say fused, means molten, melt. Don't use water. So here I am going to use a potassium chloride. Same. Potassium chloride. Now instead of M, I put potassium. Instead of X, I put chlorine. Solid heat. And this M is changed into potassium ions, and these X ions turn into chloride ions. This is no. Yes. Now this is molten potassium chloride. Molten potassium chloride. Now here, there the molten potassium chloride. Molten sodium chloride. Molten magnesium chloride. So X for chloride ions, M for potassium ions. Yes. This is a molten, here, fused molten form. So when you are going to pass electricity, the electric current is going to be passed. So these two chloride ions, and the reason I told you that chlorine atom does not exist, so it must be in the molecular form. That's why I directly write in the gaseous form, chlorine the gas. You can collect chlorine gas at anode. So chlorine gas can be collected at anode. Down cell, many times I repeat this process. Down cell, they are written in your book also. This is down cell. Sodium chloride, potassium chloride. So here the chlorine gas is collected at the anode oxidation process, and a reduction here instead of the M I wrote potassium. Yes, this is a potassium in the liquid form. Positive 1 charge is given here, and potassium can be written in the atomic form, but I told you the reason because of these two electrons should be equal, so I must write in the molecular form chlorine. That's why I multiply by 2, otherwise no need for this. So this potassium iodide is going to be formed, so you can collect, and students, potassium is more reactive than sodium. Potassium is more reactive than sodium. Potassium can react with water minus degree, even at minus 100 degrees centigrade, the potassium can react with ice. So it's highly reactive. Reactivity increases down the group. In the last lecture, we will discuss the reactivity of the metals and non-metals. So you can get the potassium metal here. At cathode, potassium metal is going to be collected. At anode, chlorine gas can be collected. So there is one process description. The diagram is given. I will explain only here up to here. Just explain the electrolytic process. How the electrical energy is going to be changed into chemical energy. So this is the page number 169. So I explain general and this is a particular according to your self-assessment exercise 7.5. Now, when I explained this process, I also told you about uses of the electrolytic cells. This is a great use to prepare chlorine gas, to prepare metals, same written in the book. Down cell, many times I told you this name. Down cell is used for preparation of sodium metal, chlorine gas, potassium metal, chlorine gas. And there is also another cell we call Nelson cell. We will discuss in later. But difference is that in Nelson cell you have to put salt in water, aqueous. So in Nelson cell you have to prepare the caustic soda, sodium hydroxide, and with the caustic soda also chlorine gas is going to be formed and hydrogen gas is going to be formed. These are two byproducts. So the actual method is Nelson cell is for preparation of caustic soda, which is also very important in industry, sodium hydroxide. This is the second. Number third, electrolyte cell used for the commercial preparation of calcium and magnesium, also same one. The use production of aluminum metal, commercially also same electrolytic process. Purification of copper. This is also I think in the last of this chapter, end of this chapter, there is a process purification of the metal. So copper, when we prepare the copper by using different methods, this is called a blistered copper, which is somehow impure. So by electrolytic process, we have to purify, and we will discuss later. The purification of this copper is very important metal in the these electrical wires. We use the copper, very important metal. Cell also electroplating. This is also very important topic. Later on we have discussed. Electroplating means the electrolytic process when we coat one metal on other, plated metals. So we will discuss later on this electroplating. And also anodized aluminium, dyeing process, and there are many other uses of the electrolytic cells. So, just revision of this topic. I told you electrochemical cells. Electrochemical cells are two types, electrolytic cell and galvanic cell. In electrolytic cell, the electrical energy is used to derive the chemical change. Then I explained the topics electrolytes and non-electrolytes. I explained earlier, and you have to see very well. You have to watch the lecture very well and make notes yourself. Then it's beneficial for you. Then I explained this electrolytic process in general and in particular. This is a cell and it contains molten potassium chloride. When I say molten, heat, potassium ions and chloride ions are going to be formed. They are in the ionic form, ionic process. So when they are present here, I dip these two electrodes in the potassium chloride. They are dipped here. These are two electrodes, anode positive charge and cathode negative charge. At anode oxidation, loss of electron, cathode reduction and gain of electrons. Connect the battery, positive terminal with the positive and negative terminal with the negative. And there is one thing very important, that electron flows from anode to cathode. Flowing of electrons. Dear students, when you are going to show the flowing of electrons, mostly the examiners ask you question. Direction to flow of electrons from anode to cathode. So these are arrows show that electrons are flowing from anode to cathode. So this the potassium material is going to be formed at a cathode by the reduction process. You see that Hofstede reduction reaction. Reduction means decreasing oxidation number. And there is a oxidation reaction here. There are two chloride ions change into chlorine gas, and there is oxidation. So chlorine gas is collected at anode. So this is the electrolytic cell, non-spontaneous, and I explained the uses of these non-spontaneous chemical reactions. So students, I think it is clear for you to electrolytic cell. Now in my next lecture, inshallah, I will explain the galvanic cell for you.